always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it.
Our target: illustrate polygons, convexity, angles, and side. A polygon can be defined as a geometric object consisting of a number of points called the vertices and an equal number of line segments called sides, namely a cyclically ordered set of points in a plane with no three successive points collinear together with a line segment joining. The term poly means many and gon means angle. Thus, polygon have many angles. This is an example of a polygon with many angles. So we have the given polygon. We can name the polygon as polygon A, B, C, D, E, and F. So we have the vertices of the polygon. What are the vertices of the polygon? We have point A, point B, point C, point D, point E, and point F. So we have the sides of the polygon. We have segment AB, segment BC, segment CD, segment DE, segment EF, and segment FA. We have the angles of the polygon. We have angle A, angle B, angle C, angle D, angle E, and angle F. So we have a regular polygon. A regular polygon, all the sides of the polygon are equal and all the interior angles are the same. For example, a regular hexagon has 6 equal sides and all its interior angle measure to 120 degrees. So this is a regular hexagon. All the sides are congruent and all the interior angles are also congruent. This is a square. All the sides are the same and all the interior angles has a measure of 90 degrees. This is an equilateral triangle, and this equilateral triangle, this is also an equiangular triangle. All the sides of the given triangle are the same, all the angles are the same. The measure of the interior angle is 60 degrees, so all the sides for a regular polygon, it is an equiangular and at the same time equilateral. What do you mean by equiangular? Equiangular means all the angles have the same measure, while equilateral means all the sides have the same measure. So in a regular polygon, a square is a regular polygon. All the sides are the same and all the angles are also the same, which is equal to 90 degrees. An equilateral triangle is also a regular polygon. All the sides are the same, all the angles are the same, which is equal to 60 degrees. In a regular pentagon, all the sides are the same, and the measure of an interior angle is 108 degrees. So we have an irregular polygon. An irregular polygon is a polygon with an irregular shape. It means the sides and the angles of the polygon are not equal. Look at the side of this rectangle. This is, one is shorter than the other. Look at the side of this figure. This is actually a quadrilateral. And look at the measure of the angles. The measure of the angles are not the same. Therefore, this particular polygon is an irregular polygon. So we have a convex polygon. A convex polygon, the measure of the interior angle is less than 180 degrees. It is exactly opposite to the concave polygon. In other book, instead of using concave, they are using non-convex polygon. The vertices of a convex polygon are always outward. Look at this particular polygon. If we try to extend the side of this polygon, this side, this segment, or this line will not pass through the interior of the given polygon. But if we have this side, we try to extend the side, segment DE. If we extend the side, and it passed through the interior of the given polygon, so this particular polygon can be considered as a concave polygon or a non-convex polygon. Look at FE. If we try to extend the side will pass through the interior of the given polygon. But in this particular polygon, for a convex polygon, if we try to extend the side will not pass through the interior of the given polygon. So this is a convex polygon. This is a concave polygon. In other books, they use the word non-convex. Again, as I have told you a while ago, a concave polygon, at least one of the angle measures more than 180 degrees. The vertices of a concave polygon are inwards as well as outwards. Look at this one. The measure of this angle is more than 180 degrees. And if we extend the side will pass through the interior of the polygon, and this side it will not pass through. This will not pass through the interior, but if we try to extend segment BC, it will pass through the interior, and if we extend segment DC, it will pass through the interior of the polygon. So this particular polygon is a concave or a non-convex polygon. So we need to determine if the given is a polygon or not a polygon. How do we know whether the given is a polygon? Actually, we have segment, no? Actually, the sides of the polygon or segment, the side cannot be a circle, a semicircle. So we are in the first number. Is this a polygon or not a polygon? What is your answer? The answer is, it is a polygon. Now we are in number 2. Is this a polygon or not a polygon? This is a polygon. We can proceed with number 3. Do you think the side of this one is a segment? The sides of the polygon are segment. Are the sides segment? No. Therefore, that is not a polygon. This figure, is this a polygon? Yes, it is a polygon. How about this figure? Is this a polygon? Yes, the sides of the given figure are segment. How about this one? Is this a polygon? That is not a polygon. It must be a closed figure. Next, so the sides are extended here. Therefore, it is not closed. Therefore, this one is not a polygon. Then, is this a segment? This one, is this a segment? That is not a segment. For a polygon, we have the union of segment. So this is not a segment. Therefore, the figure is not a polygon. Is this a polygon? Yes, that is a polygon. Is this a segment? That is not a segment, therefore, that is not a polygon. Is this a polygon? Yes, that is. Next, we have this one. Is this a polygon? Yes. And for the last number, is this a polygon? Yes, that is a polygon. Determine if the polygon is convex or concave. We have the first number. Do you think the figure is a convex polygon? If we extend the side and it doesn't pass through the interior of the polygon is convex. Then if we extend the side and it passes through the interior of the polygon is concave. So for number 1, the answer is convex. We have number 2. The answer is convex. For number 3, what is the answer? Again, that is a convex polygon. For number 4, that is a concave polygon. For number 5, that is a concave polygon. For number 6, that is a convex polygon. For number 7, that is a concave polygon. For number 8, that is a convex polygon. For number 9, that is a concave polygon. And the last number, that is a concave polygon. So we have trigons. Trigons are polygons who have 3 sides. They are nothing but triangles. These trigons or triangles are further classified into different categories such as isosceles triangle. All the sides are unequal. Isosceles triangle. 2 sides are equal. Equilateral triangle. All the 3 sides are equal and all the angles measures to 60 degrees. So, isosceles triangle, all the sides are unequal. Look at the given figure. The sides of the given triangle are not the same. So, we have an isosceles triangle. 2 sides are equal. So, this side is congruent to this side. So, we can consider this triangle as an isosceles triangle. We have an equilateral triangle. All the 3 sides are equal and all the angles measures to 60 degrees. So all the 3 sides of the given triangle are the same and the measure of its angle is 60 degrees. Quadrilateral polygon. A quadrilateral polygon is also called a 4-sided polygon or a quadrangle. The different types of quadrilateral polygon are square, rectangle, rhombus, and parallelogram. This is a quadrilateral, a 4-sided polygon. Quadrilateral A, B, C, D. Pentagon polygon. The 5-sided polygon is called a pentagon polygon. When all the 5 sides of the polygon are equal in length, then it is called a regular pentagon. Otherwise, it is irregular pentagon. This is a regular pentagon, and this one is an irregular pentagon. So we have a hexagon. Another type of polygon is the hexagon, which has 6 sides and 6 vertices. A regular hexagon will have 6 equal sides, and all its interior and exterior angle also measures equal. This is a regular hexagon with 6 equal sides and 6 equal angles. Equilateral polygons. The polygons whose all the sides are equal are called equilateral polygons. For example, an equilateral triangle and a square. All the sides of an equilateral triangle are the same, Therefore, this is an equilateral polygon. All the sides of the square are the same. Therefore, this is an equilateral polygon. Equiangular polygons. The polygons whose all the interior angles are equal, such as a rectangle, are called equiangular polygon. So this is a rectangle. All the angles of a rectangle are right angles. Therefore, this rectangle is an equiangular polygon. So we have the types of polygon with 3 to 20 sides. For 3 sides, we have a triangle, also known as trigon. For 4 sides, we have a quadrilateral. We can also call this one as tetragon. For 5 sides, we have pentagon. For 6 sides, we have hexagon. For 7 sides, we have heptagon. For 8 sides, we have octagon. For 9 sides, we have nonagon, also called as enneagon. And for 10 sides, we have decagon. This is a triangle, a quadrilateral, a pentagon, a hexagon, a heptagon, an octagon, nonagon or enneagon, and decagon. We have also the following figures for our polygon. So we have different names. 9 side, they call it nonagon. In other book, enneagon. 11 side, they call it undecagon. In other books, they use hendecagon. So for 11 side, we have hendecagon or undecagon. For 12 side, we have dodecagon. For 13 side, we have tridecagon or triskidecagon. For 14 side, we have tetradecagon or tetrakidecagon. So we have for 15 side, we have pendedecagon. For 16 side, we have hexdecagon. 17 side, hepdecagon. For 18 side, ocdecagon. For 19 side, enneadecagon. For 20 side, we have icosagon. And for n side, we have engon. So we have the following figures for polygon. So we have 3 sides for triangle. 4 side, we have quadrilateral. 5 side, we have pentagon. 6 side, we have hexagon. 7 side, we have heptagon. 8 side, we have octagon. 9 side, we have nonagon or enneagon. 10 side, we have decagon. 11 side, we have undecagon. And 12 side, we have dodecagon and the others. We need to give the sides and the angles of a polygon. This is polygon GREAT or polygon grit. So we have the given polygon. Polygon GREAT. What are the sides of the polygon? The sides of the polygon are segment GR, segment RE, segment EA, segment AT, segment TG. We have the angles of the polygon. We have angle G, angle R, angle E, angle A, angle T. So we have angle G, angle R, angle E, angle A, angle T. We have the number of diagonals of a convex polygon. We have a quadrilateral. What is a diagonal? A diagonal is a segment joining any two non-consecutive vertices. Consecutive vertices, so we have A and B are consecutive vertices. B and C are consecutive vertices. If we draw a segment joining any two non-consecutive vertices, we can draw a diagonal. So we have one diagonal, we have another diagonal. Diagonal AC, segment AC, and another segment, diagonal segment BD. So how do we find the number of diagonals of a convex polygon? The number of diagonal is defined as n times n minus 3 over 2, wherein n is the number of sides. How many sides are there? We have 4. 4 times the quantity of 4 minus 3. 4 minus 3 is 1. 4 times 1 is 4. 4 divided by 2 is 2. So we have 2 diagonals for a quadrilateral. We need to find the number of diagonals of a convex pentagon. So there are actually 5 diagonals. We have segment AC, AC, this is AC, segment AD, this is segment AD, segment BE, we have segment BE, segment BD, segment BD, and segment CE, we have segment CE. So we have 5 diagonals. Now we need to find the number of diagonals using the formula D equals n times the quantity of n minus 3 over 2. How many sides are there? There are 5. So we have 5 times the quantity of 5 minus 3 over 2. 5 minus 3 is 2. 5 times 2 is 10. And 10 divided by 2 is 5. Therefore, for a pentagon, there are 5 diagonals. So we need to complete the table. I want you to use your Google to find the number of sides for tetracontagon, pentacontagon, octacontagon, enneacontagon, and hecatontagon. So after finding the number of sides, you need to find the number of diagonals using the formula D equals n times the quantity of n minus 3 over 2. I am giving you time to answer the problem now. So we have our answer: tetracontagon, 40 sides, pentacontagon, 50 sides, octacontagon, 80 sides, enneacontagon, 90 sides, and hecatontagon, we have 100 sides. So for our number of diagonals, we have the following answer. So kindly check your answer. Thank you for watching.